Thank you for listening to the Maker in the Mix podcast, where we discuss design, innovation, and all things concrete.
Good morning, and welcome to episode 22 of the Maker in the Mix, and welcome to, if you're watching this on video, my new sheet recording studio.
Yes, Caleb has a fancy studio.
So fancy, it's a bed sheet to block the incredible mess of all of my children's toys behind me. We're in the process of remodeling, and this was the office when before we bought this house from my in-laws, and it just became the dumping ground for all of the toys. Lauren actually just bought a new toy organizer that we're putting in the sunroom, which is just to the other side of this wall. And so all toys will be organized, and I'll have like some semblance of an office here in the next couple of days. So I'm excited about that.
Yeah.
But for now, bed sheet.
Mm-hmm.
Dun, dun, dun.
Yeah. That's like that one drawer in the kitchen that catches everything.
Oh yeah. Well, it's funny. Yesterday, I told Lauren, I was like, "Hey, can you get my my box cutter out of the junk drawer?" And she was like, "It's not in the junk drawer." I walked in, and it was exactly where I thought it would be. And she was like, "No, that's the tool drawer. The junk drawer's over there."
Oh, okay. So we have specialized junk drawers.
Yeah, we do.
Yeah.
Yeah. It's funny. Well, and part of the bedsheet thing was because she was like, "Caleb, your studio looks terrible. You need to fix that." And I'm like, it's Tuesday afternoon. I don't have time to fix that before tomorrow.
Right.
So, anyway, so before we kind of get rolling on something I'm really excited about, I was talking to Martin Duckett, who is a really, really good friend of mine. For those of you who don't know, he and I administrate a Facebook group together. We talk all the time. He's a really, really close friend of mine. He and Ashley both are, actually. And he told me that something that I said on the last podcast could have been misconstrued. So I just want to clarify really fast. What I said, and I'm not going to quote myself because I don't remember the exact words. I'm going to paraphrase it. But what I said was that if you, as a listener, CCI alumni or not, if you're interested in learning an aesthetic or a look, I think the word I used was technique. Jeff and I are really good at, helping you learn those things. What Martin told me was that could have been misconstrued as we're interested in stealing somebody's signature look or technique or something. And I just want to unequivocally say that's not true. And that's not what I meant. And so, apologies to anybody who interpreted it that way. But what I meant was we, over the last 10 years as an artisan, I've developed the means of pleasing my clients. So they'll come to me with an aesthetic they're looking for, and it might not even be concrete. The origins of my marbling technique were because I had a client who really loved the aesthetic of Carrara marble, but didn't want to live with Carrara marble. That was the whole thing. And so I spent some time kind of starting that. And I've got a picture, this is from 2015, that I could probably find. So while Jeff's talking in a minute, I'll probably dig it up and throw it up on the screen. But I developed that finish for that purpose, and then it gained some popularity with my clients, and so we decided to teach it. So all of that to say, I've developed finishes, Jeff has developed finishes using our knowledge of the material. And so if you have an aesthetic that you're interested in, our knowledge of the material can help you get to that aesthetic for your clients. So at no point, and it's so funny because it was so far outside of the realm of what I was intending to say that I didn't even consider that as a possible interpretation. And so, if you are, anyway, that's where I'll leave it. That's not what I intended to say. And if you interpret it that way, that's not what I intended to say. And so hopefully that makes it clear for you.
So first of all, if I sound funny, I've got the cold that's going around.
Well, I kind of do too, and I'm like, Jeff, did you give it to me from Raleigh?
Yeah, my sneezes are that hard. I've only had it for like 4 or 5 days, so it's not that bad. But I sound funny and I can't get any sleep because I cough when I lay down. So, life's rough, right? First world problems.
Mhm.
So as many of you know, like I've been doing this, talking to people. I actually started teaching before I formed CCI in 2001. So that's 22 years, right? 22 years of dealing with students. Even before then, I remember there was a gentleman in New York who emailed me, and he's like, "Man, I really want to do this." This is way in the early days. Might even been in 2000 or somewhere in that time frame.
Mhm.
And he was like, I want to do this something, right, for himself. I'm like, sure, I'll help you. I can't remember him. The email's long gone. And so I helped him out. Now, again, bear in mind, this is pre-GFRC days. So life as we know it today is so much easier on so many different levels than it used to be back in the Stone Age, right? So anyway, he did his thing, he did his project, and he's like, "Man, this came out so good. I'm so happy for your help. How can I want to repay you?" And I was like, "You don't owe me anything because I want to help people." This was kind of like the precursor of help teaching people. He's like, "Give me your address. I want to send you something. I own a paint company and I'm going to send you some pigment." I'm like, "Really? This is cool." Now, again, remember, this is way before specialized anything. And like I used to get my pigments from a local, I think it was a masonry supply company that carried Davis pigments. They actually carried in bulk, 50-pound bags, and they blended their own colors. They had their own blends for brick, stuff like that. And Davis colors are fantastic. They're a great source of your basic, black iron oxide, yellow iron oxide, red iron oxide, that sort of thing. And the most exotic color you could get was, a green, the standard chromium oxide green. And allegedly they had a cobalt blue, but it was never ever available and it was very expensive. So blue concrete, for those of you who know the name, was a very rare, that was the holy grail. If you could make blue concrete, that was like the bee's knees. And he sent me a 50-pound bag of the most intense ultramarine blue pigment I have ever seen. And it just like ultra intense. Like any blue pigment now is not that intense. This was intense. So naturally I got really excited. Like, I have the holy, he's giving me the holy. And he also gave me like a beautiful brown pigment, like a deep, deep chocolate brown pigment. And many of you know brown is not an easy, for the standard browns out there, like a deep, like Davis colors. I still remember the name. It was on the East Coast, it's one number. I think it's 60735. On the West Coast, it's a different number, 61078. I don't remember which was which. I could get both, but they're identical. They just have a different number. I don't know why they do that, but they do. And brown pigment is a blend of black, red, and yellow iron oxides.
Which, as an aside, you have an excellent blend. If you're interested in Buddy Rhodes pigments, call them and ask for espresso.
Yeah, I had
that's one that you blended up or had them blend up, and
I had them make a custom CCI espresso brown that doesn't do
beautiful.
what the common dark brown pigment does,
I use
which
it all
is
the time.
have
for
a
years.
purpley pinkish undertone to it. Which there's nothing wrong with that. Like if you've ever looked at real walnut wood, it has a lot of purpley undertones in parts of the wood, but it also has very golden undertones in different parts of the wood. Well, I did not want a purpley undertone brown. I'm getting way off track here, but it's all.
Yeah, anyway, that was a total aside. Continue, I'm sorry.
So he sent me this brown pigment and this blue pigment, and I'm like, cool, I got to make samples. As you should when you get new pigments, see what they do. And I happened to make the blue pigment using, there was also a company that recycled glass, and I got buckets and buckets of free crushed glass. Like,
that's awesome.
plate glass kind of stuff. So it had a lot of the fines in it and crushed stuff that was, basically a fine aggregate, a fine gravel. Call it a fine gravel. So I made this blue sample with that because I thought it'd be kind of cool. And I made the brown sample with my regular concrete. And the next morning when I came in and demolded the samples, the blue sample looked great. I mean, it was just as vibrant, and the brown sample looked like it had a fungus on it because parts of the brown were turning pink.
Oh, goody.
Like bubblegum pink. And I was talking to my dad, and he's like, yeah. So
what is your dad? Well, what I know he's retired now. What did he do for a living?
My dad is a retired industrial chemist. He specialized in coating optical coatings for the printed circuit industry. Printed circuit, not circus. Printed circuit industry, but also for like mass media.
Very cool.
Printed stuff. There's another cool story. Maybe I'll tell it one day about how they won a huge contract with a company in Japan by what they did when they picked up the people from Japan at LAX airport.
I'll try to remember to remind you of that.
Someday we'll get to that. Now this is in the 70s, right? So this is like early stuff. And anyway, he was saying that a lot of synthetic pigments, and this is why you just can't use any kind of stuff in concrete. The chemistry of the synthetic pigment, and a lot of them are called lakes, like aluminum-based lakes. I don't know what that means, but
well, we know what aluminum and concrete don't. These chemistries.
Well, yeah, but it's like saying table salt, sodium chloride has sodium in it, and chlorine's a poison. It doesn't work that way. It's that these chemistries of these synthetic pigments are specialized, and they can be stable in certain pH levels and unstable in other pH levels. And paint pigments tend to be stable at lower pH levels, more neutral, around a 7-ish. Concrete, as you should know, is very alkaline, has a very high pH, 11, 12, 13. And what was happening is, as the cement is hydrating, one of the byproducts of the cement hydration is calcium hydroxide. And calcium hydroxide is what drives the pozzolanic reaction that makes your concrete better. But that makes the concrete extremely alkaline. And what was happening was the pigments were breaking down. And so the brown one happened to break down into a different color. It eventually just disappeared and kind of turned grayish. But for a time, it was this bubblegum pink.
What about the blue? What did it do?
The blue, somewhere I still have the sample, like 20-something years later, and it's still vibrant blue.
Cool.
But I made it in regular concrete, and it turned gray the next day. So what I was seeing was, because it was basically an all-glass aggregate-based concrete, and the glass had a lot of fines in it.
It was reflecting?
No. The glass, as you know, VCAS is very finely ground glass.
Yeah.
The glass is a pozzolan, and the fine particles, and there's lots of technical articles on this, lots of research on this. Very finely powdered glass acts as a pozzolan, consuming the calcium hydroxide. So what was happening is the glass was protecting the pigment.
Oh my gosh, that's wild.
Specific instance. So I basically had 50 pounds of stuff that I couldn't use.
Oh, sad news. Do you still have that pigment? That'd be fun to play with.
I know. I gave it away to an artist who could use it, right?
Oh, that's awesome.
So that's my little story. But getting back to, the more serious thing at hand is, over the years, I've had many, many very confidential conversations with students, people that contract with me. And it's really important to know that, when somebody tells you something in confidence, you never, ever divulge that. There's no statute of limitations on that. No. So that's something that I hold very, very dearly. And, it's important to me because that's why people trust us.
It's funny because, like, we have a mutual friend, and in fact, he was in my my ultimate class, October 2013. Dylan
Yes.
Myers, unbelievable artist. I mean, he's like the definition of artist. Dylan, if you're watching, we all know you're a little bit insane. It's okay. But I love him. We talk to him all, like I talk to him all the time. I know you do too. And he told me the other day, he was like, you know, there are exactly two people I've ever told how to do my finishes and not lied about it.
And you're
that's
watching
you
right
and Jeff. Because he was like, if anybody ever asks me how to do it, I generally lie about it.
Yeah.
Which I find hilarious. But like, I take that really seriously. Like, one of my favorite grays to use actually was his gray, and I credit him for it all the time. My silk is his silk. I even used the same name because he was like, dude, use this gray. It's really nice. And so like we share pigment recipes all the time, and but you know, I know how a lot of people do their signature looks. And I have zero interest in sharing somebody else's, creation with the world without their permission. So, if ever we wanted to like teach a signature look, we'd invite that artisan or, get express permission to do so.
There's an important thing that I think everybody in this industry should do, right, is experiment. And we all take inspiration from each other, other industries and other materials, stone, wood, that sort of thing.
Well, like you had that Steve Millard does that amazing wood look.
Absolutely. Cool. You want to learn how to do that? Go see Steve. Like,
yep.
I don't even want to try because first of all,
so much of that requires the skill of an artist's eye.
Yeah.
That's so subjective. And then the other thing, and it's interesting too, because if I ever tell somebody how to do like my marbling, for instance, if you go, we have it on the website. Jeff and I recorded this is how Caleb does his marbling technique. You can buy that for $99 or something like that on the website, CCI website. But I guarantee you, if you go do exactly what I did, it's going to look a little different. It's going to look like you. If Jeff, you do Buddy Rhodes' press technique, which we've had Buddy come teach on multiple occasions.
They look totally different.
It looks different. If I do Buddy's technique, it looks different. Like at some level, you can't replicate somebody else's look because it's you doing it. And there's an artistic element to that. And I want to add this, and then we'll move on to something else because this is all the airtime that needed. But one other thing. So, the points, what we meant was we want to teach you how to fish, not give you fish.
Yeah.
We are not even remotely interested in utilizing someone's signature technique without their express permission or participation. Signature looks never look the same twice with two different people. And fourth and finally, this is not a backtrack. This is a clarification. So what I said, I meant. The way it was interpreted, I did not mean.
Well, you can't control how people interpret things or try to put a spin on things.
Right. So I'm just trying to clarify what we meant. And the other thing that I've said to a couple of people that's really important, I think, to note is that CCI, the main bones of our course structure are not finish related. We teach a couple of finishes because they're interesting, right? Like high spray. We'll do a high spray in class. Or we'll do a little bit of marbling in class or whatever, because they're interesting. So we teach a couple of different casting techniques, but the goal of Ultimate specifically is to teach people how to have that skill set for themselves and how to have the ultimate, skill set for themselves, business, understanding how to run this as a business, your suppliers, your clients, your pricing, and obviously your concrete. So, at the base level, we are a foundation kind of cornerstone institute as opposed to a finish class.
Yeah.
So just want to make that.
We're not a paint by numbers kind of class.
No.
I think what's an important extension of that, and what I was moving towards, it's early for me, right? I haven't had a lot to
Yeah, I
sleep. So
make
my
you get
brain's
I
a little
make
slow
you
right now.
I make
Is
you do these early.
um as an artist or as a craftsperson or as a maker or whatever label you're comfortable placing on your head, um, you're going to have customers saying, "Hey, I like this look. Maybe I want to." You don't know how to do terrazzo, or you're not comfortable doing it, or you haven't done a lot of it, or whatever, right? Whatever look. It kind of behooves you to experiment. So early on, and this is something we encourage, and I've encouraged from day one of teaching, is everybody kind of has to find their own style. Like you're going to do your own thing. And as Caleb said, is if even if Picasso stood next to me and showed me how to paint, it's still my hand and my brain fumbling around trying to draw or paint or whatever. It's never, ever, ever going to look the same.
Yeah.
So it's now mine. And the more you experiment with different looks, try different colors, try different techniques, try different casting techniques, try different processing techniques, the more you understand your material, the more you can master your material, which is, I think, is incredibly important, because now you're not dependent on somebody else.
Yeah.
So you can spend a lot of time on your own figuring these things out, playing in your garage, experimenting, whatever you want to call it, right? For folks who are trying to do this as a business, they don't have time. They usually don't have time, right? And so that's where
We're
we
trying to
can step in. We
we're
cut
trying to
the
cut the
learning
arc off the
curve
learning
off,
curve.
because we've already done a lot of stuff. And that's where we're coming from, is like, look, if somebody says, I want this terrazzo stuff, something, how do I do it? What's the best way to do it? Well, cool. I've done it many times. Caleb's done it lots of times. Lots of other people have done it lots of different times. Does that mean it's my technique? No. Does it mean it's anybody's technique? No. It's out there. But and especially if we have a relationship, I know what your skills are. So I'm going to help tailor the process that I think is going to get you the results you want in the shortest amount of time within your skill set. So if I know you don't have expensive machinery, I'm not going to say, oh, well, you need to use a blah, 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 because you don't have one. See where I'm going with this?
Yeah,
so
absolutely.
it's all about, moving you towards the place you want to be successful. And maybe it's being successful with a particular project, or maybe it's being successful with creating a new market or a new look. It's all that. That's what we're here for.
Absolutely.
Let's shift gears and talk about Alpha.
Yes, let's.
So Alpha is a product line. It's used as like the name of something, but it's a product line. And it's a product line I've started developing a couple of years ago. And this is a sort of a long-term plan. And the first products are foundational building blocks. And there are three. I can't count. There's three of them. There's Alpha Polymer, which is a dry polymer. There's Alpha Fluidizer, which is a very, very, very powerful super plasticizer. And there's Alpha Defoamer, which is a powdered defoamer. Those are three building blocks that address the current needs for a broad range of people who do things with lots of different ingredients. So the reason why I came up with the dry polymer, there's plenty of other dry polymers on the market. I can think of at least three offhand. Is like, why do we need another one? Well, I want my own, right? Because I have plans for it. And you've already heard our strong professional, technically based reasons for having a polymer in our concrete. And if you haven't heard in the past, we get better strengths with polymer than without. So there's measurably higher strengths. And So there are lots of folks who use Rapid Set CementAll as their base mix, which is fantastic. We do too. It's readily available for lots of folks, and certainly in the U.S. and other places that distribute it. And Alpha Polymer is a fantastic addition to it. Makes so much easier to use and boosts its strength quite significantly.
What was it? 47%.
47% increase in the 1 day flexural strength.
It's kind of impressive,
Just a little bit impressive.
Just a touch.
So having that, we'll call it the raw polymer. So if you use Alpha Pro polymer, you don't need defoamer in it. The reason why I have that separate defoamer is for folks who still use something like Forton or some other liquid polymer, or have, they use a liquid super plasticizer that has lots of foaming problems, because a lot of liquid super plasticizers, because they're liquid, tend to be very foamy. Not all of them, but many of them. And just as a simple aside, a really easy test and to see if your super plasticizer has foaming tendencies, take a quart cup of water, just fill it halfway. Doesn't matter, right? Put a good splash of your super plasticizer in there, and then I used to take like an handheld electric egg beater, cake mixer, and I just take one of the mixer blades and stick in a cordless drill, and you whip that water with the super plasticizer in it, and you'll get like this big head of foam. It'll get foamy. So that's one test. The second test is, how long does it take for that foam to go away? Because if it's more than just a few seconds, that means that foam of that super plasticizer
stable structure
is creating a foamy structure in your concrete. Excuse me. And that's the role of the defoamer, is to break that foam down so that all that air the foam that's being created is dissipated, so it doesn't trap air bubbles in your concrete, which makes foamy, lightweight, weak concrete. So if you are not using my polymer, you should be using my defoamer.
Yeah,
so there's that. And then, of course, the fluidizer is,
it's 20-pound sledgehammer.
It's the 20-pound sledgehammer. It's a 10-kilo sledgehammer for our metric folks.
I mean, it's wild. It's so powerful, and this is anecdotal kind of fun that I've been playing with. I mean, I've been playing with this for months, right? And I've dialed it in. And one thing, so if you're interested in using it, I was talking to somebody out in California who is really interested in using it, and really excited about it. And, one of the things that I kind of advise people when they're talking to me about it is, before I tell you like where to start with the plasticizer, I need to know what kind of mixer you're using. Because if you're using, a single head column mix like an X06, which is a fantastic single head mixer, Jeff has one at my shop. I'm not going to say I have one.
He has most of my mixers. He has my Eimer. He has my double-headed mixer. He has one of my single-headed mixers.
Yeah. And so if you're using that, what Jeff's been doing, which is anywhere from like a 0.5 to a 0.7, and this is very specifically. So I'm gonna throw numbers out, and then don't take them as gospel truth. Like, call us and talk to us about it. Okay.
Yeah. A 0.7 is like incredibly. It's like right on the edge of being too much.
Yeah. Well, yeah. And you're using a 0.3 water cement ratio with that, correct?
Yeah.
Okay. So with that mixer and that percentage, that's working for you. My mix, I use primarily a Rimcraft mini mixer, which is a much higher shear single head thing, vertical shaft mixer. And my personal preference is a 0.29 water cement ratio. And I'd actually like to experiment with going down a little bit, because less water, better.
Oh, totally. I've gone down to a 0.21. So
yeah. And which is UHBC territory, is it not?
Yeah.
But for me, at my current happiness mode, is a 0.29 water cement ratio and between a 0.35 and a 0.4 fluidizer. So I'm having to use little more than half of what Jeff's having to use because my mixer is more efficient.
Yeah. The mixer
I
makes
have
all the difference
found
in the
that
world.
the dual head Columix, the XO55 Duo, is
Very good
about
mixer,
the
by the way.
same as my mini mixer from what I need standpoint, maybe just a touch more fluidizer. So just be aware that when you're playing with the fluidizer, it does depend very much on your mixer. I would imagine that the Eimer would require in the 0.6, 0.7 range, but I haven't played with it, so I can't really speak to that from experience. That's a guess. But what I was going to say was I was mixing it. I was playing with a 0.4, which was beautiful. I mean, it was perfect. So I posted a video on a Facebook forum of me pouring. I had done some kind of high spray, stuff. I was looking for a specific finish, and then I wanted a SCC. Which, if you don't know what SCC is, it's self-consolidating concrete. It's all the rage in GFRC countertops right now because you don't have to use a face coat, and it's wonderful. So we can talk about that in a minute. But point being, I wanted to SCC my backer, and I was running a 0.4 plasticizer, and it was really funny because I added like 3/4 of a teaspoon at the end to just tweak it a little bit. And that was enough to put it just barely over the edge where some of the stuff started to float at the top. So it didn't segregate, but it had a little bit of pigment bleed. So, I mean, it's that powerful where we're talking you just go barely over the edge.
What was your batch size? Like 100-something pounds?
111, I think. 112, something like that.
So a few grams and 100-something pounds of concrete. It's powerful. Like, that's what it's for.
Like, the most powerful.
Yeah. So, like in designing a mix, I'm going to kind of shift aside. When you're designing a concrete mix, you have to think about, all right, what are you looking for? Like, what's important in a mix? How are you going to cast it? What are the aesthetic qualities, et cetera, et cetera, et cetera. So ultimately, for me, there's lots of different ways to make a mix or to take a stock mix. Let's just use GFRC as an example. So, we're throwing words around, letters around. We're throwing letter salad around. GFRC, glass fiber reinforced concrete. ECC, engineered cementitious concrete, developed by Professor. A professor, I can't remember his name. I can never remember it. In the University of Michigan in the 90s.
You talking about who invented ECC?
Yeah. UHPC was an extension of reactive powder concrete, pioneered in
UHPC was Lafarge, correct?
Yeah, Lafarge did a lot of it. So ductile was the first commercial UHPC. There are many other ones now. These are all, we'll call them siblings. So they're all centered around cement-rich, fine sand grain concrete that utilize high volumes of, we'll call it engineered fibers. So commercial UHPC often uses steel fibers, which are just miserable to work with in reality for us. So the substitute is PVA fibers or glass fibers. GFRC obviously uses glass fibers because it's in the name. And, there's other ones like in a different life prior to me getting into this, when I did research for the U.S. Navy, I didn't work with concrete directly, but I had in my own test lab, and in the same building, there was a different program that was concrete focused. So that was really interesting. So they did really cool stuff. A lot of it with carbon fiber in concrete. So carbon fibers as well as carbon fiber wrapping. So, one of the things they do is, like a ship, a pier or a wharf that a ship is brought up to. We're talking about Navy ships, like big military ships, not like you go out and go charter fishing kind of stuff. This is big stuff. Well, a lot of these piers use piles to hold them, right? And concrete piles are a common thing. So they would cast like a 200-foot long concrete pile, full scale. And, these things are huge. I don't know, 2 feet around-ish. Our facility was big, so everything looked small from a distance. And they would lay it on the ground in a test fixture and actually break it. So they had big loads. They were designing the concrete to be strong, so they would load test the pile to failure. So they'd break it, figure out what it took to break it, how strong is this thing. Really, it was a flexural test. But the cool thing was, then they would repair it. So they would fix it, and they'd do different techniques to fix
again,
it.
I imagine. Would they test it again after they repaired it?
Absolutely. So that was pretty cool. Yeah.
This is a total kind of aside that I find very funny. The other day, I asked Jeff. I was like, what was your clearance level? And he goes, I can't tell you that. I'm like, well, okay.
And then he said,
would you have to kill me?
And I said, I wouldn't have to be doing the one. I wouldn't be the one having to do that.
So, I guess you take confidentiality sort of seriously.
Mm-hmm. Yeah. When I was doing my security clearance background application for just to apply to the job, I had to give references back 15 years. Now I'm in college, so 15 years was like, I don't know, elementary school level. So yeah, I take it seriously. Where was I going with this? That's what happens when you get old. You get distracted and you get lost. So all these concretes, UHPC, ECC, they're all siblings in the same family of similar kinds of properties, want different things out of it. Obviously, the nuances of the mixes are different.
Mm-hmm.
And the things that are important about the mixes are a little bit different, but they're all kind of similar things. So bringing it back to where we all are, right? I can take any one of those mixes, and by using less superplasticizer and or less water, I don't want to say it's trivial, but it ain't rocket science. It ain't rocket surgery to make a stiff clay-like mix out of that, right? That's easy.
I think you can really call this a Swiss Army knife because, the plasticizer is so powerful that you can pull it way back.
Or simply just use a weaker one if you don't want to make it fluid.
Yeah.
So it's easy to make a stiff mix. Like, you just don't use any, and you can see how hard it is to mix some of these mixes. The opposite end of the spectrum is where it's difficult. My goal, and because I have so much experience with concrete, real world and theoretical from training, is if I want to make a very fluid concrete that flows, so SCC or direct cast or whatever, and I want to have a high flexural strength. Compressive strength, it's a nice number to know, but it's only peripherally related to that. Like if you're designing a column, yeah, you're going to want to know compressive strength, but we're not making columns. We're making, flat.
Right. I mean, I think, and to bring it into one thing that I've said a number of times is that, the ability to translate information to something where somebody without technical knowledge could understand it easily. And by no means am I saying that somebody without technical knowledge is not intelligent, because that's just not the case.
Yeah.
So I think that the ability to translate that technical knowledge into layman's terms is where expertise meets teaching. And so I want to bring down that flexural strength term a little bit, because why do we need that term and not compressor strength? Because it sounds amazing to be like, oh, I got 21,000 psi. I'm like, that's cool. How brittle is it? You know, and because glass is phenomenally strong, right? It's not flexurally strong. Porcelain, there are all sorts of things that are really strong that are also very brittle. And so what we need is to be able to transport our pieces. I mean, so if you're doing precast GFRC, we got to move it.
Right. It's
Once
going
it's
to
in
want to
place,
naturally.
it doesn't matter how flexurally strong it is. It's moving it that matters.
Yeah.
Now, I
We
say
do more
it doesn't
to our
matter. It does
concrete.
matter because if the house settles or whatever, there are definitely applications for flexural strength once it's installed. But the main thing is it's got to move.
Yeah. We as manufacturers of stuff generally put more stress on our pieces than our customers do. In general, I'm waving my hands and generalizing, because I'm going to cast it today and demold it tomorrow. I want it out of my shop ASAP. So it's still gaining strength by the time it's actually installed.
Right.
So, we're stressing the pieces early on. So that's, 28-day strength is a nice, warm and fuzzy number to know, but it's completely irrelevant to us because who here actually has a piece of concrete sitting in their shop for that long? Nobody.
Right.
I'm looking at, like, I do tests. I'm doing a test today. I do 1-day tests. 1-day strength.
Well, and that's,
I do 7-day strength tests. And I'm also doing some long-term stuff because where we're going to go with this topic about alpha is I'm doing some 28-day tests. I'm doing 1, 7, 28-day tests to see, because I want to have that number. I want to have that long-term, like, it's not fully cured, but it's close enough to be fully cured kind of number. Mix that is, here's a real good analogy. I can take any kind of concrete and I can just dump a ton of water into it, right? And I'm going to make it really workable, like really, really workable. You could pour it, it'll slop around, it'll self-level, but is it strong? No. What's challenging is to make a mix that gives you that fluidity, that workability, that castability,
and have it also
and still have the strength consistently. Like, that's the other important word, is it's got to be consistent. Because if sometimes it does it and sometimes it cracks, what good is it? Like, if you can't trust your mix, so it's got to be consistent.
And not all viscosity modifiers, not all admixtures are created equal. Because you did a test recently with what was it, Adva 555? I don't remember what it was.
Yeah,
with a liquid superplasticizer, and you found that at higher doses, it really messed with your flexural strength.
Absolutely, yeah.
And so you can't just say, well,
to be fair to that admixture, that's in line with their dosing recommendations, right? So when you start maxing out a superplasticizer, for instance, or any admixture, right? You don't want to turn it up to 11 because you start to get into some issues where, sure, you're getting.
But
let's
Jeff,
like driving your car. Like
11.
If you drove your car by just mashing down the accelerator and flooring it all the time, you would go really fast. But would you have control? Could you go around corners? Are bad things going to happen because of that? Sure. If the intent is to go fast, absolutely. But you also want to do it safely and have control. So the reason why I made Fluidizer is it gives you that ability to achieve incredible workability without having to absolutely, hit your dosing super high to where now it's actually affecting your strength. And I'll tell you this much. I only know 2 other companies that actually have bothered to do strength tests on their product and actually publish those, which I think is very telling. Most people don't have any means to or know how to
You're referring to in the craft concrete industry?
In the craft concrete industry, like this is bending strength, right?
Mm-hmm.
Bending. How it's not how much.
Are you willing to say who those other companies are? I mean, they're public, so I'd like to give people the opportunity to go check out some of those numbers.
Trinic publishes their numbers, and
they have some really good testing equipment.
They have very good testing equipment, and then Buddy Rhodes publishes their flexural. They do 1, 7, and 28 days strength wedge. They also do compressive,
awesome.
But it's the flexural that matters.
Yep.
And I applaud them for that. That's, to me, that says that they pay attention to their concrete and they understand.
Yeah, they want to be transparent.
And we will too, of course. If I want to make something very fluid and I want to do a direct cast, like last year and a half ago or something like that, we cast a big sofa, all direct cast, very complicated form. The whole casting.
I'm trying to remember if that was from scratch or if that was a Buddy Rhodes blended. I don't remember.
It was CementAll, I believe.
It wasn't. No. It was Portland because we had to make a specific.
I think it was from scratch. And this is all well before we had any Alpha that was available. And you're dealing with casting. It's got to go. Picture sofa. It's got to go down 30 inches across the back, up, which would be down the seat because we're casting upside down. And the flow path was many, many feet through a 1-inch channel. So this concrete had to flow a long way. And it was difficult. Now, the molds themselves were incredibly heavy, several hundred pounds. So it's not like they could, hitting with a rubber mallet was not that effective. But we made it work. Like the casting came out great. Was it flawless? No. Do I care? No. I mean, it's concrete, right? Making strong, durable concrete that you can make flowable is difficult. So that's why finding a super plasticizer that lets you use it at a 0.4 or 0.5 dose, nowhere near the range where you're going to start affecting your strength. Like if you're up near 1%, 0.7 is where I'm at now, and I'm still getting incredible strengths, like really incredible strengths. So I know it doesn't affect my strength at that high dose, but I've seen other mixes that I have to use even a higher dose to get the same kind of flowability, and there is a test for it. You can get your flowability and not know and not realize that all of a sudden you're actually taking strength away. You're sacrificing your concrete, and maybe not long term, but I'm talking about short term. I'm talking about one day. Like when you demold that piece, is it going to break? And think about all the work that you're going through to build a mold, especially a complex mold. I mean, it took us like 3 days of building that mold. Mm-hmm. Lots of material. Like we used 10 sheets of melamine. So 10 sheets of, how much are 10 sheets of melamine and a whole, multiple people for 3 days building a mold? That's expensive, right? Plus the material cost. We had like 1,400 pounds of concrete. Imagine spending all that time making your concrete really flowable, but I'm using a very weak super plasticizer that I have to overdose. And then all of a sudden, as you're demolding it, it breaks. And I got to start over.
Yeah, imagine if we made a sofa and you sat a bunch of people on it and it cracked.
And it cracked, yeah.
Well, it didn't do its job.
So those are the kinds of things that we try to think about. It's not the stuff that most people like, surface level stuff. It's the more nuanced stuff where
it's the comprehensive parts of things.
That's where knowledge and experience come together to go, hey, you got to think about this. And it's what most people
like you have to have both. I mean, we both have a lot of experience, but we've also taken the time to develop the knowledge.
Mm-hmm. That's fluidizer. So those are so the polymer, the fluidizer, and if you're going to use the polymer, absolutely get the fluidizer so you can take advantage of it.
Oh, it's a phenomenal combo. And anecdotally, like I've used Rapid Set for years. I love Rapid Set, and it is made far and away better by Alpha Polymer, but I will say, I've been getting like the confidence level that I've been getting out of my Portland. I mean, that was one of the reasons that I switched to Rapid Set, was I just didn't feel good about, I don't know. There was something that made me feel uneasy about flipping things that quickly in certain Portland bag mixes.
Yeah, when
That
your
I was
concrete
using.
feels a little soft the next
It
day.
felt a little soft, a little too flexible. It just, I don't know. And that's why that's honestly the reason I switched to Rapid Set. And now I've had to overcome a lot of color things with Rapid Set. 'Cause although it's very consistent in color, it's tan, and the tan that it is not very pretty. And so you got to use a lot of white pigment to bring it back and give. I mean, I can make some ridiculously vibrant color. In fact, one time I made a royal blue, and Jeff was like, "You can't make that color in Rapid Set."
Oh,
like,
it's
watch me. But it probably cost me $800 to make two vanities in that color. But all of that to say, that's why I used Rapid Set. Now with the Alpha Pro, I mean, I'm blown away by the stiffness the next day on like 1/2-inch panels. They are honestly rivaling Rapid Set, and that's something that our testing has shown us. So Jeff, I wanted you to get into two things. One, downpacked and relabeled. Alpha, the polymer is a new formulation of that's exclusive to us.
Yeah.
So I just want to be clear on that.
It has a pretty unique characteristic. First of all, it is an acrylic polymer, and only acrylic polymers function as curing polymers in GFRC. As I mentioned before, that white book right there, that's the handbook on polymers and concrete.
Hey, you're getting better at pointing.
You're getting better at it. It's like yeah, getting better. It's the white book right there on polymers, right? So there's styrene bead-eating rubbers, SBRs, there's EVAs, PVAs, this, that, and the other thing. Lots of different kinds of polymers used in concrete. Most are adhesives, bonding agents, right? So your Acryl 60s, fantastic bonding agent. They don't function as curing agents. And that's why in the GFRC industry, as mentioned in prior podcasts, the whole commercial GFRC industry was made commercially viable because of the adoption and inclusion of very specific and very expensive acrylic polymer for curing, because it replaced, and this is the performance spec written by the Precast Concrete Institute of America. When you use a curing polymer, you only have to cover your piece under plastic for 1 day. When you demold it, it can be out in the open air. And its 28-day strength, flexural, bending strength, will be equal to or greater than, I'm paraphrasing the spec here, but it's very close, will be equal to or greater than that same concrete mix made without polymer that was wet cured for 7 continuous days. So imagine, you make your piece of concrete, you keep it under plastic, and you keep it wet. Can't be just under plastic. It has to be kept in a 100% humidity or 95% of humidity environment.
Would screw with your aesthetics if you're trying to do this.
Yeah,
decorative.
And you're getting all kind of mess on for 7 continuous days before you can do anything to it. That's impractical.
Right? Oh yeah, it's a big bottleneck.
That is why. That's why it was used. So, go on, Caleb.
Yeah, well, I wanted you to, if I could ask you to get into specifics on some of the testing you've been doing and like the strengths you're getting as far as you're comfortable. I know we're going to publish some of these numbers and some of them may not be final. So anything you're comfortable with being,
Well, so my goal, obviously when you start developing a product, you have a vision of where you want to go. And it should be obvious, we're going to have a bag mix. And we're also going to have we don't have a name for it yet. We're going to have an admix pack, right? Mm-hmm. So right now we start with the fundamental building blocks, the polymer, I got my pencil here, but you can't see my hands. I was talking with my hands. I have my
Well, you've
polymer,
noticed I've been using my little highlighter.
the fluidizer. Of course, the fluidizer is not going to be blended into it. I don't want to do that.
Right.
Because as soon as you put a super plasticizer in a mix, you kind of make it a one-trick pony.
Yep.
And I don't want to do that. So I'm working on like the admixture pack, which will be the polymer and a tailored blend of pozzolans in a correct proportion to give certain characteristics. And then, of course, once you have that, a bag mix is trivial. Maybe it's not trivial, but it's a lot easier, right? It's a lot easier.
It's an easier lead.
Fluidity, castability, direct castability was the main focus. Like, it has to be able to do that, because if you have a mix that you have to dump a ton of super plasticizer in to make it flowable, maybe you're sacrificing another important factor, is that's early flexural strength. And by early, I mean 1 day.
Well, and ideally too, you want to be able to do that without having your glass fibers visible.
Right.
So that was one of the factors as well.
That's somewhat dependent on how you cast and if you vibrate and things like that. So
yeah, absolutely.
Measuring bending strength, the ASTM test is ASTM C947 or 947C dash whichever version. I can't remember if it's 01 or the dash 01 is the year the ASTM test was amended. And it's specific for glass fiber reinforced concrete or fiber reinforced concrete. There are other flexural tests, like for pavement. I can't remember what the ASTM test is, but the samples that are cast are big, thick blocks. They're like 6 inches on a side and so many inches long, and it's a single point test. So if you're doing a sidewalk, for instance, you'd use that test. It's for pavement. For the kind of concrete we make, the test is different. You cast a sample that's typically 3/4 of an inch thick or less, and the test, the way I do the test is I cast a 14 by 14 inch panel. There, you can see my hands, and it generally specs out about 5/8 of an inch thick, about 16 millimeters thick. And the reason it varies is the overall density of the mix. And because
which you are also measuring.
Which I'm also measuring.
And it is unbelievable.
Yeah. So once I cast these panels, and this is according to the test procedure, is you cut them into 2-inch wide strips. So I have a tile saw with a diamond blade, and I cut them, and they're cut just before testing. And then they go into my flexural test machine. So I built a flexural test machine that's functionally comparable to an industrial universal test machine. It's far stiffer, so it can measure modulus. I can't measure modulus because my machine's not stiff. I don't measure that. But I do measure the bending strength. So I can measure the first crack load, and I do that visually. Because if the concrete doesn't have a crack in it, is it there? If you can't see it, is it there? And then I can also measure ultimate strength, like peak strength. Excuse me. That's the way I can measure flexural strength. So I know the load that I applied. That load is applied at a very uniform rate of 0.1 inches per minute of down. It's in a 4-point bending, which is appropriate. The spans, all that's correct. I can take out the effects of twist and variations in the sample. So if the sample's thicker on one end or thicker on the other, or thicker on one side versus the other, that's all taken out, so there's no twist or bending, because that would skew the results. And these are identical, set up the same way the universal test machines are. And I've also compared identical samples cast at the same time. I didn't test on mine, and I sent my samples off to a test lab in California with certified test equipment. They tested the same samples, and our results compared very, very closely, statistically identical. So I know I'm very comfortable with the numbers I'm getting. Now, these are just for me to evaluate. So I have an apples to apples test. So that gives me the sense of strength, right? The most important right now. But what about flowability? How do you evaluate that? Well, in regular concrete, there's the slump cone test. So it's that metal cone that you dump your concrete in, you rod it, and you lift it up, and you see how much it settles. In self-consolidating concrete, which is really a term that applies more to conventional concrete, aggregate-based concrete cast in with steel rebar. That's the context. It's not a definition, it's a context where it's used. We're really doing fiber reinforced concrete that's also cast the same way. So I guess it kind of applies. We want our concrete we want to pour it into a mold, and we want to have it flow out very easily so it fills the mold, captures all the details, things like that. And that's a more difficult test to measure.
Right.
And there's a test apparatus used for a slightly different indication, but part of it is a slump. It's called a flow cone. So the apparatus is like a bronze platter that you cast a little sample on, and there's a little crank that makes the platter go up and down, and it's like an impact. Like if you took to go form a concrete, you tapped it on the table, all right, you're agitating the concrete. Well, when you turn the crank and it goes up and down, and it's a very fixed and in uniform degree of banging, right? And then the cone part is a machine bronze cone that's, you picture a cone, but it's chopped off at the top. So it's open at the top and it's open at the bottom, and it's smaller on the top and bigger on the bottom. And the inside at the bottom is 4 inches in diameter. It's 2 inches tall. So it's a pretty sharp cone. It's like 2 3/4 inches of opening at the top. And you fill this it's for grout, right? You fill it full of grout. And when you lift the cone, because of its shape, most of the concrete just comes out easily. And then you scrape off the inside, put it on that cone, and then you do your test. Well, for the flow cone test is you have a sheet of plastic, smooth plastic, that has rings painted or cut into it on the underside. And these rings are certain distances apart. And because this cone is of a certain size, you fill it full of concrete and you raise it up. It's centered on these rings. You measure the spread of that patty of concrete. So it's like a pancake batter. And the further it flows out, the more flow you have. So it's very sensitive to everything that goes in the concrete. Like how much sand, the sand percentage, the sand gradation, the fiber content, the fiber size, all that sort of thing. And a good target number is like an 8-inch, 9-inch spread. If you start to get spreads that are too high, it generally means you're starting to get segregation. So the cement paste, which is really runny, tends to separate from everything else. And so that's why you get like a 10 or 12-inch spread, is when you get this watery segregation around the edge, and you don't want that. Likewise, if you only get a 6-inch spread, that means that mix is still very loose and workable, but it's not a fluid. It doesn't flow out because it's starting at 4 inches. Yeah, it's starting at 4 inches and it's only going a little bit. And there's a time factor. So you evaluate the spread after 2 minutes. So you pull this up and you don't touch it. It's got to be on a perfectly level table. And you lift it up and you don't touch it. You don't vibrate or work it. And gravity pulls it out. So I'm consistently getting 8 to 9 inch spreads on my mix, which is ideal. No segregation, nicely flowable. That's what a lot of UHPC tests are doing. That's their yardstick for flowability, is this flow cone. Well, I didn't want to buy a flow cone, so I made one. I 3D printed one, so that's mine. And because the cone is there just to fill the concrete, it has nothing to do, no bearing on the test itself. I don't have to buy, like, I don't know how much these things are. They're like $500 or $1,000 because they're, test apparatus that has to be held to very high standards and last for years, that kind of thing. It's like, I'll just 3D print a new one when it wears out, but there's no wear on. But that's how I measure the flow. That's how I can evaluate time and time again. I have the same surface in the same spot, done the same way. And these are all important characteristics when you're doing tests. Is you have to take out variables that could affect something. Like if the table that I was doing wasn't level, or I moved it around, that would affect things. Or if I bumped the table while it was running, that would affect things. And then, so I measured density. After I have my cast samples, I have a block of concrete, and I have a digital caliper, and I measure its dimensions, and I try to make it as rectangular as possible. Back calculate, I know its weight, I know its bulk volume, I can get a bulk density. So it's a real density.
What's the theoretical maximum density?
Excuse me.
Like zero air?
Hang on a second. Let me pull that up. For mixes similar to a common UHPC, and definitely GFRC. Yeah. Pardon me. I got to pull up the correct.
Well, while you're pulling that up, I want to move backwards to the marbling technique thing.
Yeah.
Just because I found the picture. So I'm going to pull that up while you're pulling your let's see, screen share my iPhoto, wherever it is. Here we go. Or the entire screen and go to iPhoto. Oh, look at that music.
Okay, I got it. So
there you go. So that's the first marbled piece I ever did, and this is what I developed the technique for. So you can see the very kind of faint veining.
It's very soft.
Very soft, very subtle. And that was that was the whole reason I developed it was for this client. So it's evolved since then. It's a little bit more aggressive.
Yeah, Well, while I'm doing this, find that big table, the big dining room table, the 20-something foot table, because that's more of a a more deliberate, higher contrast. All right, so when you're doing density of a base ingredient, you have to look at, like, obviously what ingredients you're using. Sand, fibers, this, that, and the other thing. I need to know what the specific gravity of each ingredient is. That's how dense that stuff is. So, like, cement has a specific gravity of 3.15. Water is a specific gravity of 1. That's by definition. So cement particles are 3.15 times more dense than water. Sand, like, if your sand was pure quartz, it typically has a density of 2.65. So sometimes your sand's about a 2.6, 2.65, 2.7, depending on the mineralogy, but it's somewhere around there. Glass fibers, they have a published density. And I usually, because there's some air in it that you really can't account for, I mean, it's there. I'll use a density of about 2.5. PVA fibers, their spec density is a 1.3. So they're slightly heavier than water. So they'll sink in water. which you've seen, right? So any number that's bigger than 1 means it's denser, it's going to sink in water. And if it's less than 1, it's going to float. If I had a perfect mix with no air in it at all, the theoretical maximum density is 139.5 pounds per cubic foot. And I don't know what that is in metric. Actually, I do. It's 2,235 kilograms per cubic meter. So 139.5 is theoretical maximum, right? You can't get it denser than that unless you start to change, like you put lead in it, for instance. So you're changing the density of ingredients. But all concrete always has air in it. And I know the numbers that I'm measuring for my bulk densities, a good average of mine is like 135, 136, which is very high. And that's typically like an entrapped air content of about 3%, which is quite low. Like, I'm not doing a ton to try to get the air out. There's always going to be air in it, by the way. It's so
what you're getting 136.
The relevant question is, does the air show up on the surface of the mold? There's always air inside the concrete. Don't let anybody fool you. You cannot.
You're selling yourself short. It's actually at 2.6%.
Yeah, 2.6. Okay. So way back in the old days, well, not the old days, but the last time I tested a Forton-based mix, I'm going to pull up this number so I have real. I was getting densities, GFRC test densities with Forton. Yeah, this is Portland cement-based mixes, by the way, not CementAll. 113.7, 111, 108, 109, 110, 111.3. So let's just say 112 pounds per cubic foot. This is why we say specifically to Forton, but by extension, other liquid polymers, you tend to get foamy, lightweight concrete, and that translates to a weaker concrete. So if I had that exact same mix, but I use Forton instead, to get that low density.
Well, I mean, and then you're testing the strength of air as a replacement for your
25%.
Yeah,
gives me 111.6 pounds per cubic foot. Which is
so as opposed to 2.6%, it's 25%.
10 times as much air.
Jeez, OP.
So
with the mix design that we're working with now, with the Alpha mix, we've got a 97.4% of theoretical maximum density.
Yeah.
Pretty friggin' impressive.
That is why I made it. And that's
and as Jeff said earlier, natural progression is we're working on an admix pack, which we have not named yet, but it is incoming. I'm going to call it imminently. I don't have obviously a date for it yet, but it's looking pretty good. I've got a bucket of it at the shop that I'm playing with, and it's unreal. I'm very excited about it. And then somewhere subsequently there will be an actual blended mix, but kind of stay tuned. I would encourage you to play with the raw ingredients because they're pretty amazing. And yes, that might be slightly inconvenient for a time, but I think it's worth it for the level of concrete we're getting with it.
So this is the special projects book that I started to
read it.
You can't see this.
I know.
So
somewhere confidentiality, you won't even tell me.
Somewhere in the middle of this is where I started testing Alpha stuff. This one's almost full with only that. So this is real shit.
Love it. So that leads me to I said you should play with it. That leads me to we're having so as I've mentioned a number of times, we're having a GFRC mastery course that really doesn't delve into too much of the business side. It's just here's the concrete. And that's 2 days, November 9th and 10th at my studio in Canton. It's the 9th because my wife's birthday is the 8th, and I'd be majorly in the doghouse if we held it on her birthday. Consequently, that's also my sister's birthday, so that's kind of funny. My wife and my sister have the same birthday, several years apart, but also my sister-in-law and my sister share a name, so that's kind of funny. So it's just a series of funny things that are total asides. But we're having a GFRC Mastery course November 9th and 10th, which would be a phenomenal opportunity if you are interested. That'd be a kind of a low cost of entry kind of. I think the price is $895. Don't quote me on that because it's on the website.
It's on the website.
But if you're interested in checking out, we're going to be using the Alpha products, casting some cool stuff, showing you some of the different things you can do with it. So if you're interested in getting a real in-depth intro into the product line that we've got going on,
but don't feel it's not a product. This is not a sales.
It's not a product demo. It just that's what we're using. I think we may use Rapid Set 2 for something. I don't know.
And we're making a bunch of different things.
Yeah.
We're not just doing flat panels.
No, this is not a demo day. It's an actual class, but it's a really amazing opportunity to to demo some of the products because we will be using them. So it'd be a 2-day opportunity to really dig in and ask us all of the questions you might have about any mix. Certainly about this one. And if you're an alumni or a business owner that wants a refresher or an update, maybe you've been in the industry for 15 years and you've been doing, a lot of spraying and you're tired of spraying and you want to learn how to SCC, or a lot of hand packing. You want to learn how to SCC. Maybe you've been like compaction rolling hand packed backer and you want to, there are some. That's certainly valid, obviously, but then we can do an SCC backer. So there's a lot of new, I've said SCC 3 times in a row now, so that's fun. But there are a lot of trends and techniques that are really doing really cool things right now that we're going to be playing with. And so if you want a refresher, this is a fantastic opportunity for that. I think I don't know what the discount is off the top of my head, but I think there is a discount for alumni. So if you are a CCI alumni and that discount isn't on the website and you want to come, please call me or Kim, which numbers are also on the website. But call us or email us, and we can help you get registered and get that. So spots are filling up. So, take advantage of that opportunity. And certainly if you want to...
Call before midnight. Don't call it midnight.
Don't call it midnight. And then of course, if you want to learn this as a career and you haven't done a ton of it, the ultimate class would be the way to go for that, which is December 4th through 8th.
Yep.
5 days, and we go through all of the stuff we're going to be doing in GFRC Mastery. A little bit bigger project for Ultimate because we've got more hands and, well, not more hands. Time. We should have about the same amount of people, but we have more time.
Time is always a limiting factor.
Yeah. And then of course, go through business, here's how to set up your shop. Here's how to set up your business. Here's how, not like the LLC stuff. We don't get into the legal part of it, but we do get into contracts. We do get into, a number of business things, how to get the right clients, your pricing, start to finish on projects, installation, templating, all of that fun stuff. So, if you are newer and want to do this as a business, as a trade, as a craft, join us in December. If you want a refresher, or if you want to do it as a hobby, or if you just want to know what it's about, come join us in November. So, there's my kind of class plug. But I'm really excited about it. It's going to be cool. So
I think that's a great place to end.
I think so too. So if you have any questions, drop us a comment. I'm going to post this on a number of social media outlets, so hopefully you see it there. So join us next week. Join us in November. Join us in December. Drop us a line. Let us know what you thought. If you have any questions about anything, we're available for. We also are available for consultations one-on-one if you're interested in that kind of thing. So definitely try to be available as we can. So
Thanks for joining us.
Thanks for joining us, and have a great week.
All right.
See ya.
See you next week.
Bye. Yeah, I'm going to have to trim this because I forgot to stop recording.
Thanks for listening to the Maker in the Mix podcast. If you liked the content and want to hear more, please like and subscribe. Feel free to follow us on YouTube as well as Instagram, Facebook, and check out the website, www.concretecountertopinstitute.com. And of course, we'd love to see you at one of our upcoming classes. Tune in next week for more informative content. Thanks.